Look up tonight. If you can see the moon, do it now. Just look. Most of your life, the moon has been there. It has been constant, reliable. It comes and goes, but it always comes back. The moon is the one thing in the sky that feels like it belongs to us. We named it. We walked on it. We wrote poems to it. We built calendars around it. The moon is ours, in a way the sun will never be. The moon is the nightlight in your childhood. It is the thing lovers point to and hold hands under. It is the reason the tides move. It is the reason you exist without the moon's gravity stabilizing Earth's tilt. Our planet would have tilted wild billions of years ago, and life would not have had the stable climate to emerge. The moon saved you before you were even possible. And yet, the moon does not make light. It never has. Every photon that reaches your eye from the moon came from the sun first. Every single one. The moon is not glowing. It is reflecting. It is a mirror so far away that you have never noticed it was a mirror at all. You have spent your entire life looking at reflected sunlight and calling it moonlight. You have spent your entire life watching the sun's light bounce off a dead rock and believing that rock was giving something to you. This changes everything about how you see the night sky. Because once you understand this, truly understand it, not just know it in your head but feel it, the moon becomes something else entirely. It becomes a lesson written in the sky. It becomes the story of how much of existence is borrowed. How much of what we call our own is really just someone else's reflection. How we live in a universe where almost nothing makes its own light. The moon is not an exception. It is the rule. We think of the moon as bright. In photographs, it blazes white against black space. In the night sky, it can cast shadows. It can turn darkness into a kind of twilight that humans once used to navigate by. For 13,000 years, before electricity, the moon was your second sun. It was the reason you could hunt at night. The reason you could see your enemy coming. The reason you could find your way home. But here is what that brightness really means. The moon is catching about 12% of the sunlight that hits it. 12%. The other 88% is being absorbed by the rock itself, or bouncing away into space, never reaching your eye. When you look at the moon, and it seems impossibly bright, you are looking at light that has already been rejected twice. The sun threw it at the moon. The moon rejected most of it. And whatever tiny fraction made it back to Earth seems so bright to you that you organized your entire civilization around it. Think about that. 12% of already traveled light bounced from a ball of dust 240,000 miles away. And that was enough to light human history. The universe is darker than you think. Even when you are looking at what seems like light, you are looking at what was not wanted. You are looking at leftovers. You are looking at the universe's discards. And you are calling them beautiful because you have no choice, because the darkness is so profound that even the scraps seem like treasure. This is the real story of the moon. Not a light in the darkness, but a mirror in the darkness. And a very poor mirror at that. A mirror so imperfect that it can only return to you a fraction of what is thrown at it. And somehow, that fraction has been enough. That fraction has been everything. But what is the moon really made of? What is the surface that is catching this stolen light? And where did it come from? To understand the moon, you have to rewind the universe by 4.5 billion years and watch something terrible happen. 4.5 billion years ago, the Earth was not yet a home. It was a storm of rock and fire and dust, barely cooled from the violence of its own formation. The solar system was wild in those days. Planets were still crashing into each other. The laws of gravity were still writing the rules of who would survive and who would be smashed to pieces. A planet called Theia was moving through space. It was about the size of Mars, not small, not insignificant, but much smaller than Earth. Earth itself was still molten, still forming, still gathering material to itself from the dust cloud that surrounded our star. The two worlds were on a collision course that neither could avoid. When they collided, the impact was beyond comprehension. Theia hit the young Earth at an angle. Not a head-on crash, something more like a cosmic slide, but a slide at 45,000 miles per hour. The energy released in that impact was equivalent to a 10 billion megaton bomb going off. Every nuclear weapon ever built by humans, combined, would not equal a billionth of that explosion. Mountains vaporized. The crust turned to liquid. The atmosphere itself caught fire. And from that catastrophe, from that absolute annihilation, the moon was born. The impact was so violent that part of Theia and part of the young Earth was torn up and ejected into space. Molten rock mantle material that had not yet cooled or formed a solid crust was thrown into orbit. This debris disk circled the Earth for thousands of years as the rocks gradually cooled. Slowly, gravity pulled these fragments together. They collided and merged and fused until they became one object. The moon, your moon, born from the death of a world, coalesced from catastrophe. The rock that makes up the moon's surface is the same rock that once made up the early Earth. It is made of oxygen and silicon and aluminum and iron and magnesium. It is covered with a layer of dust called regolith dust, made from billions of years of asteroid impacts and cosmic rays breaking down the rock itself. This dust is not like beach sand. It is sharp. It does not pack down. When the astronauts walked on the moon in the 1960s, they found that the regolith would not hold their footprints cleanly. The dust clumped and stuck to their suits in ways that no Earth dust ever does. It was alien dust, dead dust, dust that had never known water or wind or life. And this dead dust is what catches the sun's light and sends it back to Earth. But the moon is not a perfect reflector. If it were, it would be much brighter. A perfect sphere with a perfectly reflective surface would have an albedo of 100%. It would bounce back every single photon that hit it. The moon's albedo is 0.12%. This means the moon is actually a darker object than many things you see every day. Fresh snow, for instance, has an albedo of about 0.9. That means snow is 7 times better at reflecting light than the moon. New concrete has an albedo of 0.55. Even the ocean on a clear day has an albedo of about 0.06 to 0.1. The moon is not that much brighter. Why is the moon so dark? Because it is covered in iron. Iron oxides rust, essentially give the moon its gray color. And iron oxide does not want to reflect light. It wants to absorb it. This is why, when you see the moon in the sky, it is not white. Look carefully. Without the camera glare of photographs, the moon is gray. It is dull. It is a dark object in the darkness, barely distinguishable from the void, except that it is slightly less void than the space around it. The sun, by comparison, is making light. Every second, in its core, hydrogen atoms are being crushed together under impossible pressure and heat. They fuse. They become helium. And this fusion releases energy. Enormous amounts of energy. The sun converts 620 million tons of hydrogen into helium every single second. Not per day, per second. In the time it took you to read this sentence, the sun has converted 2.5 billion tons of hydrogen. All of that mass becomes pure energy. All of that energy spreads out in all directions, a wave of photons rushing through space at the speed of light. The moon sits 93 million miles away from that furnace. It is receiving about 1.36 kilowatts of power per square meter of surface. This is enough energy to power a microwave oven from every patch of ground the size of a dinner table. The moon's surface is bathed in this power, and then it refuses most of it. It absorbs 88% of what hits it. It turns that energy into heat. It warms up to 127 degrees Celsius in sunlight hot enough to boil water instantly. Then it radiates that heat back out into space as infrared radiation, as thermal energy that will never reach Earth, never become anything except a tiny contribution to the heat death of the universe. And 12%, just 12% bounces back toward us. That reflected light travels 93 million miles back to the Sunday. It travels another 93 million miles to reach Earth. Some of it reaches Earth and bounces off the atmosphere. Some of it reaches the surface and bounces off clouds. But some of it reaches your eye. The photon that left the sun 170 years ago has traveled 186 million miles to reach you right now as you look up at the moon. The light you are seeing is old. Not in the way the light from distant stars is old. You are not seeing the moon as it was years ago. The moon is only a light second away, so you are seeing it as it was 1 second ago. But it is old in a different way. It is recycled. It is second-hand. It is the universe's leftover, being shown to you as treasure because you have evolved on a world where the darkness is so profound that even scraps of light seem precious. And here is the part that breaks the scale of human understanding. You are looking at the only light source that has ever been close enough to you to seem bright, while being completely unable to make its own light. The sun is 109 times wider than Earth. If you took 1,000,000 Earths and stacked them, you could not make a Sunday. The sun is so large that light takes 8 minutes to travel from its core to its surface. 8 minutes. The photons generated in the deepest part of the sun have to fight their way outward through millions of miles of plasma and radiation before they reach space. The light we see is not direct light from the nuclear reactions. It is light that has been absorbed and re-emitted trillions of times, working its way slowly upward, like heat rising through water. And the moon is 240,000 miles away from all of this. To put that distance in perspective, the moon is as far from Earth as it is possible to travel if you circumnavigate the entire Earth's equator 9 times. It is the distance you could drive in a car for almost 6 months without stopping. It is 9 times the distance between New York and Tokyo. It is so far away that it takes 3 days for a spacecraft to reach it, traveling at speeds no human can survive. And yet, at night, the moon seems close. It seems intimate. It seems like it is yours. You can see the craters on its surface with your naked eye. You can see the dark and light patches called the lunar seas and highlands. You can watch its shape change through the month. You can point to it and touch it with your finger and cover it with your thumb. The moon is an illusion of proximity. It is massive and distant, but it is close enough that it seems personal, close enough that we claimed it, close enough that we walked on it, close enough that its gravity reached down and wound itself around Earth's rotation, and made itself indispensable to every life form that ever evolved here. But it is still just bouncing light. It is still just a dark mirror, returning 12% of what was thrown at it. And somehow, that was enough to matter. That was enough to change everything. The moon is not alone in this. Everything you see that is not a star is light borrowed from a star. The planets are dark. Venus is bright only because it is close to us, and because its thick atmosphere reflects light well. But Venus is not making light. Mercury is not making light. Jupiter is not making light. Even Jupiter, which radiates more heat than it receives from the sun because of its internal structure, only makes infrared radiation. All of the visible light you see from Jupiter is bounced sunlight. The galaxies that you see in telescopes, the ones that seem to be glowing across billions of light years, are glowing because of the billions of stars inside them. But if you could somehow turn off all the stars, the galaxies would disappear. They are only visible because they are full of light makers. The darkness is the default. Light is the exception. This is what the moon is really teaching us. We live on a borrowed planet, under borrowed light, in a borrowed moment of time. The light that we see by is light that was made before we existed. The light from the sun was created by nuclear reactions that have been running for 4.6 billion years. For most of that time, nothing was here to see it. The light was just flying through space, empty space, going nowhere, reaching nothing. And then, by chance, a planet formed in the path of that light. Life emerged on that planet. And for the first time in the history of the universe, the light had something to see it. The light finally mattered. The moon was part of that chance. The impact that created the moon happened, and the moon locked Earth's climate into stability. And that stability allowed life to emerge, so the light from the sun could finally be seen. Every photon bouncing off the moon's gray surface is part of the same story. The story of a universe that was dark and empty, and then, by accident, briefly, became conscious of itself. But it is only brief. It is only borrowed. Humans have been looking at the moon for as long as humans have had eyes. But humans have only understood what the moon is: a spherical rock orbiting a larger rock, made of material blown off the Earth by an ancient impact for less than 100 years. And we have only landed on the moon for less than 60 years. This is nothing. This is a blink. The moon has existed for 4.5 billion years. It will exist for billions more. And humans, in all of that time, will be here for perhaps another 10 billion years if we are very lucky and very careful. And then, eventually, the sun will expand and incinerate the moon and Earth and everything that ever lived here. The light will stop being borrowed. There will be no one left to see it. This should not depress you. It should change how you look at the moon. When you see it next, remember that you are looking at something that is not supposed to be there. The moon should be dark. It should be invisible to you. It is only visible because of a catastrophe that happened 4.5 billion years ago. It is visible because gravity arranged the dust just right. It is visible because you evolved with eyes that could see that particular wavelength of light. It is visible because the sun is shining, and because light travels, and because the moon happens to be in the way. None of this was necessary. All of it was chance. The moon is borrowed light, and so are you. The atoms in your body came from stars. The energy that powers those atoms came from the Sunday. The light that you see the moon by is light that the moon could not make itself, that the Earth could not make itself, that could only come from a star, from that massive furnace 93 million miles away that will eventually die. You are a creature made of stardust, powered by starlight, looking at a gray rock that is bouncing starlight back to you. You are part of a chain of light that extends back to the beginning of the universe and forward to the end of the universe. You are a temporary interruption in the darkness, a brief moment when the universe became aware of itself. The moon shines with nothing of its own. Neither do you. You are both just reflections. You are both just the universe's way of bouncing light back at itself and saying, "I see you." And then, in the darkness, that is enough. Look up. The moon is there. It is dark. It is gray. It is 240,000 miles away, and it is catching light that has traveled 93 million miles just to reach it. That light bounces. It travels another 240,000 miles. It reaches your eye. That light, which is not the moon's, which is not the sun's, which is borrowed and passed down and ancient and temporary, reaches your eye. And for just a moment, you are not alone in the darkness anymore. The end.